Okay, so you remember what we did last time. We had some OpenGL examples. We understand now what is ortho 2D, what are the values, and what happens if we change these values between different numbers. So there are four coordinates: minus x, which is x minimum, x maximum, then y minimum, and y maximum. Okay. Here in this example, we define it to be the same size as the number of pixels in the window. So the dot initialized window size, or the initial window size, it has a value of 640 in x-axis. This is the number of pixels, and 480 pixels in the height or in the y-axis. Okay, so we set up the same number of possible coordinates in the orthographic mode for OpenGL, which means that each point in OpenGL is equal to 1 pixel. Okay, and it can be different. We saw that. Okay, we can also have this GLU ortho 2D starting from some negative value. So this is scaling. Okay, scaling between left, right, and top, bottom, and this scaling applies to the number of pixels, so it will automatically adjust the number of pixels per unit. Okay, so in one example we started with minus 2020, so left side of x was the minus 20, the right side was plus 20, top of the window was which was plus y, it was also 20, and bottom of the window, the negative y, was minus 20. So in that case, the center of the screen was 0, 0. Okay, in the current situation here on line number 42, we have the bottom left as 0, 0, not the center. Okay, so the center value will be between half of the x, which is 640 divided by 2, that is 320 in x-axis, and 240 in y-axis. That will be the center in this window. Okay, now let me run this example once again to see what we did last time. So here we create random points. Okay, we generate random points, and it seems that these points are only gray color. So if I see here, we generate random, oh no, this is not gray color, this is random value. Okay, between 0 to 8, it will be from 0 to 1, because you get a random value from 0 to 8 point something. Okay, and you divide it by 8, so that will give you a value of 0, between 0 and 1. Okay, and we use this value in the OpenGL color function, which takes 3 floating points. Okay, this one here in the beginning, it sets the background, it is random, it is random here, but we don't use random. We use the fixed value of 0.5, 0.5, and 0.5, and that's why we see that these are same color. But we can have used the R, G, and B values here, okay, instead of 0.5. So 0.5 is the middle way between black, okay, pure black, and pure white. So this is exactly what we call the gray color. Okay, so these dots, after maybe a minute or two, the complete screen will become gray color. Why? Because randomly we choose points. So these random points can, right now you see the white spaces in between, and the reason is because they have not been selected randomly, because there are 600 multiplied by 640 multiplied by 480 possible points. So some points, they may be repeated many times because it's random, and some points, they may still not have been selected, so they are still white. But after a while, probabilistically, the whole screen will become gray color. Okay, and we can replace this gray color by any random RGB color which we choose here. Similarly, the X and Y positions, they are random between the screen pixels. So this is where we put this in the screen coordinate, screen location. Okay, so we know about the magic dots. This is one project about random points. Then there was another one which was used to create an empty window. Okay, there was nothing except that we had yeah, the empty window. Okay, yeah, it's empty window. So in empty window we had modified that to draw lines. Yes, okay, so the empty window would be created by draw, which in the first statement clears the window. Then in the second statement it changes the color of drawing to red because it's RGB. The first R is 1, which means like 255. Okay, that is full intensity for red. The green and blue, they are 0, so it's pure red color. And we GL flush, but because we don't draw anything on the screen, so this will just have a blank window. If we, instead of using the draw, if we choose the other function, which is draw line, okay, so we have one draw function, and then we have the draw line function that we specify as our glut display function. Okay, so the draw lines, what it does is, first it sets the point size to be 5, okay, which means the width of the line, okay, how thick the line is. Then we just draw 2 random points. Okay, if you wanted to draw lines from left to right or from top to bottom, it's very easy. We will change this function. Instead of drawing 2 points, we will use the draw line. And you see here my window ortho 2D, because I have not specified the ortho 2D, so it means that I have the coordinates as between -1 and +1. Okay, so let's modify that very quickly. I will have GL lines, so they will be lines as the number of coordinates. We will see. Let me choose to have the first line as x is -1 and y is 0. Okay, so that will be the left side of the screen in the middle, because as I explained, there is no GLU ortho 2D here. And when it's not here, it means OpenGL. Oh, it's here. Yeah, it's between 0 and 100 and 0 and 100. Okay, so let's use that. We should have a line from the left side to the right side. Okay, so from the left side, the x is 0. Okay, this is actually bottom left. You see x and y both starts the minimum at 0. So the bottom left is the coordinate system such that the bottom left is 0 0 and top right is 100 100. Okay, now think about this. How can we draw 2 lines perpendicular to each other which pass through the center points? Okay, so we want to make an axis system. Okay, so xy coordinate system with this 2D orthographic coordinate system. What do you think? 0 0 is the bottom left and 100 100 is the top right. So first think about the center. The center will be 50 50. Okay, so both lines, they should be passing through 50 50. But what should be the starting point of the horizontal line on the left side? Okay, so we know that the y coordinate will be 50, but the x coordinate will be 0. Okay, so the first point will be 0 50. You need to understand this. Think about that logically. Okay, 0 and 50. Or let me draw that to make it clear to you. So if I make it a square so that we know exactly how does it work. Okay, this is almost 600. Yeah, okay, so down I can see that it is almost a square, 600 by 600 almost. Okay, so I want to have lines like here. So this is black line. Okay, I can begin. This is the center, it's very clear, and the width is also quite good, so I can have a line like this. Okay, and then I want to have another line like this. That's what I want. Okay, in my OpenGL system. Now, how do we choose the points? So from the code, I can see that this point here, the bottom left, it's 0 0, okay, and the top right point, which is here, okay, that is let me choose the size to be smaller, 20, so that is 100, okay. So this is the top right point, 100, the bottom left is 0 0. So what should be this point? What should be this point? This point. So this is just, we need to know just for mental map that between 100 and 0 0, this is 50 50. Okay, so now I know that my x and y are 50 at the intersection. So moving on the left side, x is 0 here, y remains 50 here, x is 100, y is 50. So from 0 50 to 150, that's one line, and here we can start from here, that x is 50, y is 100, and down x is 50, y is minus 100. So these are the 4 points. The first 2 points will have a horizontal line, the next 2 points will have a vertical line, and we need to have 4 points, okay. Less than 4 are, let's say, 3 points, we will still have one line, and having 5 points we will still have one line, 2 lines, okay, not 3 lines, okay. So let's see how does it work. Okay, so as I explained, the very first point on the left side here, this is x is 0, y is 50, the next one will be 150, okay. So the next point is 150. So that is one pair of points that will give me one line from left to right. Let me copy that and have another pair, okay. So the other pair will start from top. Now on top we know that the y is 100, but it's in the center, so x will be 50, okay, and the same line goes through the center, so x is 50, but y, now it comes to the bottom point, so sorry, it is 100, not minus 100, because we start from 0 0, so that is y will be 0. So these should be the 4 points. Am I clear or not, or am I right or not? Let's see that. Okay, sorry, I did not change one thing, that my default project was random point, so let's change that to the first one, which was about empty window. So that I set up as the starter project, empty window, and when I create that, okay, now the color is blue because I at some point I had the GL color to be 0 and 0 and 1, but at least we know how do we draw those lines, okay. Now you can modify this code accordingly if I modify this here, okay. So you can expect any coordinate system, and you should know how to draw, for example, this horizontal and vertical lines for that. And here I have a square window, but it need not to be square, it can be different, okay. But remember that this thing, it does not depend on the pixels, okay. This is the coordinate system, so even if it's not square, still you will get those lines, okay. So for example, let me break this window such that it's 800 by 400, okay. If I start it now, so although it is not perfect square, but from the point of view of OpenGL, what we have is that this line is in the center, okay. We don't have the same value like in terms of pixels, the values have been changed, but in terms of coordinate system we are still in the middle, okay. So this is my 0 0, this is my 100 100. Now on y-axis I have my number of pixels divided by 2, because my number of pixels here are divided by 2. So think about this logic, and it's very important to understand. Okay, let's create a new project now. We will add a project and we'll try some more things. So there is a project which draws a line, very similar code, but thing. So I can say that it's not random, it's line scanning. Okay, it's line scanning, for example. Okay, and what is done in this code, I will just open it to show it to you. So in the line scanning, I will add a source file, existing one, and it is where, let me give this path to this pathway, and the name is, okay, this shouldn't, okay, let me change it, this is not random points, line scanning. Okay, if I open line scanning, okay, what do we have here? Okay, this is magic dots. Okay, fine, there are no errors, and let me make this to be my default project. Okay, when I start it, and let me run and see what happens, then we will discuss it. Okay, we don't see anything except that there is a dot here. Okay, there is a small dot, and let's understand what's happening here. Okay, what you see is, okay, this is idle 2, that's the reason, because here, okay, you see, okay, this is idle 2, this is magic underscore dots, and this is magic dots, that's totally fine. This is the display func, and my idle func is idle 2. I have glut main loop, the clear color, the background color is white. I have the initial window size to be 600 and 480, and this should be a randomly scan line, so this should be different, the title. Okay, what do we have? In this function, I find a value of x, and this is a mod of 640. Why 640? Because I have 640 pixels. Okay, so it will keep incrementing every time. Okay, but when it becomes 640, it will start again from 0. So x will be between 0 and 639. Okay, so from 0 to 639, this will keep like increasing and starting from 0, ending at 639, then coming back to 0. We say that when x becomes 0, y is y plus 1. Okay, percent y 480. Well, it's only we change y when x restarts. So we increase y by 1 when x restarts, otherwise the y value will not be changed. So the y value will only be changed if x becomes 0. Okay, and then we have the values for RG and B to be 0. Glut post redisplay means to paint the screen once again. Okay, to draw on the canvas. Now what should be drawn? Here we selected three components of a color. So the color is basically black. R is 0, G is 0, B is 0. So we have chosen the black color, and x and y position, they are increased. So starting with 0 0, x and y, they both are 0 0. And what is our 0 0? Just like in the previous example, we have the 0 0 to be the lower left. Okay, so ortho 2D, we start from the 0, and 0 is the lower left point. 640 and 480 are the right and top points. So starting with x and y 0 0, we increment that. Now idle function is what is executed when there is no change in OpenGL. So when it's the idle function not doing anything, so it will just because in the program we are not doing anything, so it's only the idle function which is being called. Okay, but at the end of the idle function we call the glut post redisplay. That will actually call the magic dots, which means glut post redisplay will every time call the glut display function. Okay, so what we learn here is that the when you don't have anything to draw, so OpenGL will not do anything except that it will call the idle function, and the idle function is doing some calculations, but before exiting the idle function calls the display function, and here the display function is magic dot, so it will run the magic dot. So in the magic dot we have this. Normally this should be only once in the startup, okay? So this GLU Ortho 2D should be set up once in the init function. Let me remove this from here and let me define it here so that it's executed only once. And when we now run the magic dot, so what's being done here is it will set the color to RGB, which is again redundant because the RGB is 0. Okay, if we were using random components of RGB, then it was fine. Otherwise for 000 it's redundant. So anyways, it's black color, and then we change the point size to 3. Okay, this should also be done only once, no need to do it again every time. And we have GL points. We draw a single point at position XY. Okay, so now you might be thinking that all this drawing is doing is draw a single point. Yes, okay, but at which position? It's at position XY, which is changed with every iteration. So that will be increasing X every time, and when X comes back to 0, it will start increasing Y. Okay, now let me check what was the problem, why it didn't work. Apparently it's working. I don't see any bug, so let's see that. Okay, yeah, okay, so previously there was a problem. What you see here is actually it's like filling the screen with black color by random line, not random lines, but the lines will start from 0 0 and they are increasing. Okay, so I hope you get the idea that we start from 0, we increase X, and at this 640 it goes back to 0, but now the Y value is also increased. Okay, so when the Y value increased, it goes to next line, and in this way we are increasing the thing. Okay, now maybe you are able to see that actually there are points, but the point size is 3. Somewhere we set that the point size is 3, so I should increase Y by 3. It will be faster then. Okay, so now it will be doing 3. Let's see. Okay, that's faster. Okay, because the point size has been increased by 3, so it's covering 3 pixels every very, very fast. Okay, how can you make it slow if you want? So you need to have some sort of sleep function. Okay, sleep it for a few milliseconds before you can continue the next. But anyways, that's not our purpose. We just want to learn how does it work. Okay, similarly I can increase this further. Let's say make it 6. Okay, and when I run it, what will happen? So there will be a increase in 6 pixels, so 3 pixels will be empty, and after that there will be a new line. Okay, so here we are drawing like, it seems like an illusion, so drawing off lines. Okay, so it will keep continuing, I think, or it will stop at Y is equal to 0. Yes, it will start again from, you see, 0, so it doesn't go off the screen buffer. Okay, so that's one more example that we know. So line scanning, and then let's create a new project and see what examples do we have. So it's about triangle. Let's check that. Okay, add a new project, and this is empty project. We will call it triangle. This is about drawing triangle. We will add a new source file, which is the existing item, and it is you see in this area, so that is a triangle. Okay, so before I can run, let me make it the default project. Or let's see first what's in here. Okay, let me call it main. Okay, what do we have here? It's very simple. There are so many comments, but here is the thing, and that's the important thing. The remaining is almost the same. Okay, so there is an if statement, a compiler directive. If you're using the Apple computer, then we will include the glut.h on the Apple system. Otherwise, on Windows system, you will have glut.h. So if you're Mac, for example, and you have installed glut, so you will use glut.h, or even on Linux, you will use this one. Otherwise, we will include glut.h. So this is the one we will be using. Okay. Next, there is one function, display triangle. It says clears the current window and draws a triangle. So this is the clearing of the color window. Okay, and clearing means set every pixel in the frame buffer to the current clear color. Okay, so the current clear color is, let's say, white or black, whatever it is. Where do we find it? We will find it here in the, okay, where do we set the, okay, here we did not specify any clear color, so by default whether it's white or black we will see, but it will make all the complete buffer, okay, every pixel in the buffer to be black or white. Okay, then the only thing that we do in the display triangle is, you see, after clearing we have the GL begin, GL polygon. We have not used polygon, I think. Yesterday we had some example in the last lecture, but what we learn now more about polygon. So we set a color. This is partially between red and green. So red and green, they combine. I think they will give us yellow if they are completely pure red and green, but this is not pure. So it might be something like dark yellow. Okay. Then we have one vertex which is at position -4, -6, and 0.5. Now 0.5 is the third dimension. Okay, and we will see how does it work. 0.5, the z-axis. Here the z-axis is 0. Here the z-axis is 0. And because of using 3 coordinates, we are using the vertex 3 version. And because we are using between 0 and 1 the coordinate system, so we are using the floating points, the F version. Okay, the color you can see, we will see the colors and we can choose that. We will even change the colors by ourselves. But what we see here is that there are 3 vertices. So it's a polygon, and because of 3 vertices we can see it's a triangle. So simply it will create a triangle with different vertices. We have already seen that if you have different vertex colors, so the triangle will be like a combination of colors in which towards the center, let's say, the 3 colors will combine, or you can say that they will have a gradient effect from one color to another color. And then GL flush is to flush the drawing command, which means that updates the frame buffer with this information. Okay, so it will draw this triangle in the frame buffer as soon as possible. Okay, finally the remaining information in the main, we don't have much. We just have the glut initial window. We make the glut single buffer, RGB, window position, window size, create window. And what is our display function? The display function is our triangle. And after that, the last thing that we should do is the glut main loop that will start our processing of this function. Okay, the drawing. So the drawing is all about creating a triangle with 3 different color vertices. So let's do that. Okay, no, once again I didn't change that, so let me change that to the default one, set as starter project. And if I run this now, okay, so it seems like a 3D triangle. Why does it look like a 3D? Okay, let's change the value of z to 0 first, and still it will look like a 3D. Then we will see more things. Okay, still it looks like a 3D. No effect. Why no effect? Because of the projection. Okay, we will learn about the perspective projection. Right now it's the orthographic 2D projection by default, so we will look at that. soon, so ignore the Z axis for right now. Okay, that will be the next program, but we need to see the coordinate system here. Okay, so we know that this point is -1 and that point is +1 okay. So what should be this axis? Okay, so this is 0 0. Okay, on the left side this is, let's say, almost -0.4 and down -0.6. so it seems like this is the first point, which is this one. Okay, the next point, let's say we want somewhere here. Okay, so the next point is 0.6 minus 0.75. This is this one. We match it with -0.6 so that they are at the same height. Okay, and finally this one remains the same. So we just changed one coordinate by changing its y value. If we run again, okay, now it seems a triangle. Now this color is, as I told you, dark yellow. Okay, this one is green and this one is blue. Okay, because of green and blue I can even make it red completely. Red, green and blue. And we get this thing. Okay, so even though it's not a perfect triangle, because here we can see this point should be a little bit to the right to have a good triangle, but this is just an example of drawing a polygon. Okay, using polygon to draw a triangle. Now we can add one vertex more to be here. Okay, that will no more be a triangle. The program name will need to be changed, but let's try one more thing. We have 1 2 3 and then 4. So 3, the third one, should come before this one. Remember the order. Okay, so they are drawn in the order, so there should be a third one here and then a fourth one. Okay, and it should be, let's say, the height should be same as this, and the x-axis should be a little more than this second point. Okay, so I need a third point after the second point. This is logical. Let's do it logically. I need a third point. I will assign this a color of, let's say, okay, 0, and let me assign a color of this. Okay, so I will have a point which will have this green and blue combined. Okay, that will give the color something like here, and then the vertex should be the y-axis should be same as the third point. Okay, the third point y-axis is 0.75, so I make this to be 0.75. Okay, and the x-axis should, let's say, if you want something like this, a trapezoid, so it should be a little more than the the second x-axis of the second point. Okay, the x-axis of the second point is 0.6, so I will make it 0.75. Okay, this is how I do it logically to see. Okay, so let me close this and run once again. Okay, something like that. Okay, so we have this color. I think this is known as fuchsia color. Okay, now this is a polygon. Still, I can add one more point here. I can add many more points here, so that will be a polygon with as many points as you want it. Okay, so that finishes today's lecture, and we will continue with the next lecture with the topic of translation, which is very important. We know about translation and scaling and rotation. These are the topics we will discuss, inshallah, in the next lectures. Any questions?